Okay, this is Geometry, Chapter 1, Section 1, basically the basis of all geometry. What we'll be going over today, you'll be using in the entire course of geometry. So in geometry, there's some undefined terms, even though I'll go over exactly what they are. They're not the formal definitions, they're just what everybody agrees on what they are. And then we'll also talk about how to draw them and name them. So a point is just a location in space. And then when you draw a point, just represent it by a dot. You name a point by a single capital letter, such as A. So that's point A. And then a point doesn't have any dimension, so basically has no thickness or width. So once I put it on the paper or on the screen there, that's just a representation of a point and not an actual point. A line, something that you went over in algebra when you graph like linear functions or linear equations. A line is just an infinite number of points and extends forever in each direction. To show that it extends forever in each direction, you put arrows on each end. When you name a line, you name a line by 2 points on the line, such as C and D. So I made the 2 points on the line. I named those points by single capital letters. And then this would be line CD. And you show that it's a line. This is basically how to name it by making an arrow above it. That shows that it's line CD. You could also call this line DC, since line DC extends forever in each direction. And then a plane, actually going back to a line has one dimension. Points, no dimensions or 0 dimensions, line, 1 dimension. And then a plane is just something flat. It has 2 sides. So you could think about like a piece of paper as a plane, or a table or a desk as a plane. So just something that's flat with 2 sides. And to draw that, what I'm going to try to draw is, it'll look kind of like if you're familiar with any of the geometrical polygons. It looks like a rhombus or possibly a parallelogram, but it's supposed to be like a piece of paper. It has 2 sides. Sometimes you could also draw a plane with arrows on all sides, because a plane, like a line, goes forever in each direction. So in a name a plane, we have to go over a couple of other definitions first before we name a plane. So the term collinear, the prefix here is co, meaning with, and then linear, line. So together on a line, points could be collinear. If 2 points are collinear, they are on the same line. In fact, any 2 points are always going to be collinear, because through any 2 points you can draw a line. But collinear just means on the same line. So above, C and D, those are collinear. If I have a separate example here, let's just say I have a line PQ. Sorry, that's a bad drawing. Still getting used to this pen here. P and Q, those 2 points are supposed to be on this line here. So this is line PQ. P and Q are collinear. If I have another point here, R, it's actually the case that P and R are collinear. Even though there's no line that's drawn between those 2 points, those 2 points are still collinear, because then I can draw a line. And then what you might hear me say quite a bit is, even though it's not drawn, doesn't mean it's not there. Okay? Q and R are actually collinear as well. Even though the line is not drawn between Q and R, I could draw that as well. The 3 points together, P, Q, and R, are not collinear, so you say they're non-collinear. Okay, any 2 points that you pick, P and Q, those are collinear. P and R, those are collinear. Q and R are collinear, but all 3 points together, P, Q, and R, are not collinear or non-collinear, because you can't just draw one line through all those 3 points. And then kind of along those same lines, Coplanar means on the same plane. So any 2 points are always collinear, which also means any 2 points are always coplanar. In fact, any 3 points are always coplanar as well. So these 3 points, P, Q, and R, are on the same plane. They're on the plane of my computer screen there. So they are coplanar. If I had points P and Q here, and let's just say if you can imagine this, you can't really see all that well. Maybe I can. If I have another point T that's not on my computer screen, between points P, Q, and T, any 3 points are always coplanar because I have a plane that goes through those 3 points. Okay, but if I have a 4th point that's above point T, then P, Q, T, and I'm not sure what I just called that 4th point, but let's just call it S. Those 4 points are non-coplanar. There's not just one plane that goes through all 4 of those points. So to name a plane, you name a plane by 3 non-collinear points on that plane. So let's just say I have points L, M, and N on this plane, then I can name it plane LMN. Because through those 3 points, there's only one plane. And if you're having a hard time getting a grasp of any 3 points always being coplanar, just think about a tripod. A tripod is made in a specific way because no matter how you set that tripod up, even if you take a couple of the legs there and then make one leg a lot longer or shorter than the others, when you lay that tripod down, it'll still be those 3 contact points in one plane. That concludes part 1. You should also be watching part 2.